Working with hazardous substances is a daily reality in the pharmaceutical industry. A safety engineer and manager work together to ensure that processes run smoothly and high safety standards are met. In this highly sensitive industry, each individual process step leaves behind remnants. When one looks a little closer, a variety of unwanted microorganisms. This situation endangers the health of employees and falls below the high standards for quality and hygiene in the pharmaceutical industry. The key task is to stop the contamination of materials and products as much as possible. One solution is bio-decontamination with chemical substances. Various chemicals are used for this. During the last decade, there has been a significant rise in the importance of hydrogen peroxide vapor as a decontaminant. The advantages of H2O2 are its relatively efficient application, its controllable usage, and its residue-free decomposition, thus having a positive environmental balance. Its chemical properties make it a powerful decontaminant, but also carry risks. One potential risk is that contact with increased concentration levels of H2O2 can lead to skin burns. Contact with eyes and mucous membranes can even lead to permanent tissue damage. And hydrogen peroxide is particularly harmful when inhaled as a vapor and leads to long-term damage to the respiratory organs. That's why many countries impose a strict occupational exposure limit of 1 ppm. In short, this substance carries a number of risks. The consequence: H2O2 monitoring is crucial when this substance is used for decontamination in the pharmaceutical industry. From use in clean rooms to decontamination of safety cabinets and insulators, and further production facilities. The monitoring of decontamination is just one of the many tasks of the production manager and safety engineer. Systematic monitoring can help facilitate the necessary validation of this process by providing the required measurement data. Moreover, targeted monitoring can reveal potential incidents immediately, enabling a direct response, and hence avoiding work stoppages or costly production downtimes. They are also tasked with specifically preparing employees for potentially dangerous situations and providing the appropriate personal protective equipment. So how can you avoid the hazards associated with the biodecontamination process? The solution: professional safety management and the proper safety equipment. Each deployment scenario is different, but there are established solutions, such as the biodecontamination of cleanrooms by installing a stationary gas detection system that takes local air currents into account. Contaminants in the entire cleanroom can be eliminated with this process. A sensor for measuring hydrogen peroxide is installed in a stainless steel adapter. This ensures a defined measurement environment. The measured values, via a transmitter, are transferred to a controller for processing. In the last step, the measurements are visualized. In the technical control room, engineers can always view the hydrogen peroxide concentration and can respond to an alarm immediately. And right before entering the cleanroom, the gas concentration can also be viewed on a monitor. Upon completion of decontamination in the cleanroom, a clearance measurement is conducted, for example by measuring the H2O2 concentration in the exhaust air. This ensures that the cleanrooms can safely be used again, thus allowing operations to continue. A further application scenario for decontamination with hydrogen peroxide is the usage in insulators. Here, a transmitter monitors, for example, the decontamination process inside the insulator, while another is arranged adjacent to the insulator to detect leaks. If there is a leak, the gas detection system responds. The increasing H2O2 concentration is detected, and an alarm is automatically triggered. Now the measures developed by the safety management take effect. The staff reach for the appropriate evacuation equipment and leave the area. The technical staff then investigate the incident and, if possible, resolve it. To deal with H2O2, they need appropriate personal protective equipment, such as a protective suit, combined with a full face mask and breathing apparatus. In addition, portable measurement devices help determine if the H2O2 concentration has fallen below the legal limit. These devices aid in the search for the source of the leak and provide the final clearance measurement. Alternatively, disposable tubes may also be used to take spot measurements. Any pharmaceutical research and manufacturing facility can achieve maximum safety with the right equipment and a customized security concept. This ensures that all process regulations and standards, like the good manufacturing practice, are met. Production runs smoothly, and staff are protected in the best possible way.